what we have studied in the last lecture?
NSSA and totally NSSA.
Yeah, we have completed the stub part.
Yeah.
We have completed our OSPF. Now I was going to start the route filtering. Okay, so before route filtering, I just missed one topic. I told you that we will be doing redistribution. Okay, redistribution. Now, what is redistribution exactly? See, redistribution is the process of exchanging routing information between different routing protocols. Okay, exchanging routing information between different routing protocols. Now, if I give you an example, like if I am having routers over here, some routers are there over here, and these routers are connected with each other. Okay, and over here I'm running, suppose, RIP, and between these two routers I'm running EIGRP. Now my EIGRP routes will be never presented over here. They will be not there on this router, and my RIP routes will not be present on this router. So to get to you can say to exchange a routing information, whatever the routes are there might be some LAN networks, some loopback networks over here. So to exchange these networks with RIP and to exchange this network with EIGRP, we need redistribution. Okay, now why we use what are the situations that we use two routing protocols? Now suppose I was having RIP was something that was used previously. Okay, now RIP is not used anymore. So previously I was having in my company, this was my route, these were my company routers, and I was just running RIP routing protocol in my company. Okay, then suppose EIGRP came into existence. EIGRP came into existence. Now I want to migrate my company's network to EIGRP. So I cannot just stop running RIP and just make the network down and just uh, completely make the network down and just configure EIGRP and then make the network up. What I will do in this condition, I'll just make a part of this running RIP. Still it is running RIP, but I'll make some routers to run EIGRP. Also. Some routers will be running EIGRP. Like if I'm having some 50 routers, I'll make 10 routers to run EIGRP and still 40 routers are running RIP. Now I am having a single network. So I want routes to be exchanged in my company. Now we have two routing protocols. So what I need to do, the routes should be exchanged between these two routing protocols. So in this situation, I need redistribution. Okay, migrating to more advanced routing protocol. This is known as migrating to more advanced routing protocol. Okay, so this is one condition in which I need multiple routing protocols to be running in my network. The second condition is mismatch between devices. Okay, mismatch between devices. Now, mismatch between devices means, suppose here I'm running EIGRP. Okay, here I'm running EIGRP, and you can say this is something my non-Cisco device. This is something my non-Cisco device. Non-Cisco device. Okay, so previously EIGRP was Cisco proprietary, or you can say now it is not a Cisco proprietary. Okay, so you can say this is a Cisco device only. This is only a Cisco device. We will take the example of previous days. So this is a Cisco device, and previously EIGRP was just a Cisco proprietary. And now these are my Cisco devices. This is my Cisco device. This is my non-Cisco devices, and they are running something OSPF. OSPF is open standard. Okay, OSPF is open standard. So OSPF is running over here. Now we need to redistribute the routes between a Cisco and a non-Cisco device. Okay, there is a mismatch between vendors. There is a mismatch between vendors. So we need to redistribute the routes between two vendor devices. At that time, we need redistribution. Understood? This is the second time we need redistribution. The third thing that the third, uh, you can say the third place where we need multiple routing protocols is political boundaries. Political boundaries means one company is taking up with another company. Okay, they are merging. Two companies are merging, and one company is running RIP, another company is running any of the routing protocol, either EIGRP or OSPF. Okay, so to exchange routes of both the companies, I don't need to just, if I'm merging with any other company, then I will not make the other company's network down completely. What I'll do, I'll just do it step by step. Some routers, then other routers, then other routers, like this. Okay, so until that I need the routes of the other company also in my network. So what I need to do, I need to do redistribution of network. So there are three, you can say, when we use multiple routing protocols. First one is migrating to more advanced routing, mismatch between devices, as I told you, and political boundaries. Okay, two companies merging with each other. Now, internal routes, there are two types of routes when we are redistributing internal routes. Routes advertised within the same protocol. External routes, routes which gets redistributed. Okay, routes which get redistributed are known as external routes. Now, whenever we are configuring redistribution, we need to configure redistribution on the router which is running both routing protocols. Router must be running both routing protocols. So now in example, this side I am running RIP. So this router, this interface is in RIP, and this interface is in some other routing protocol. Might be it is EIGRP or OSPF, any of the routing protocol. Okay. So this is the router on which I will be running redistribution, the router that is running both of the routing protocol. Got it? We have to change the metric values. We have to change the metric values. Now, here are some of the list of the routing protocols: RIP, OSPF, EIGRP, and their metric values. RIP is done with hop counts. OSPF metric is cost. EIGRP is calculated. EIGRP metric is calculated based on the value of bandwidth, delay, load, reliability, and MTU. Now we need to change the metric value, means for RIP, I need hop counts. Okay, whenever I am redistributing EIGRP, so EIGRP metric will be bandwidth, delay, load, reliability. But whenever I am redistributing it inside RIP, RIP will not understand bandwidth, delay, load, or MTU or reliability. It needs hop count. So whenever I am redistributing, what I will say, I will change the EIGRP metrics of EIGRP routes to hop counts, which RIP understand. Okay, so inside EIGRP, I will say redistribute RIP. Whenever I am redistributing RIP inside EIGRP, I will advertise the RIP with the metric value of EIGRP. Okay, so you will be cleared. It will be cleared when we'll be doing practical. Just you need to know, whenever we are redistributing, we need to change the metric value, because the other routing protocol will not understand the metric value of the redistributed one. Okay, so let us see practically how to configure the things. I have shown you, but I have not explained you the things. I have shown you how redistribution work. Okay, but I have not explained you the things. So currently I have explained you why we need redistribution. Now I will explain you how to configure the things. Let it get started. Okay, so this is the topology that we have already know, you're already familiar with. Now we will only take R1, R2 and R3 like this diagram. We will only take R1, R2 and R3 only as in consideration. Will not take R4. Okay. In the later parts we'll take include R4 also. For start we will only take R1, R2 and R3. Okay. So let me start the router. Now I already have the screenshot. Okay, this is my topology. Now what I'll do, first I'll look into RIP and EIGRP. Okay, so this part will be in running in RIP. And these routers and these part, I can take the loopbacks also, or I cannot take the loopbacks, or you can say R1 and R2 completely are in RIP. Okay, here I am running RIP. And between these routers and these loopback and this LAN, I'm running EIGRP. Understood? This is my plan, and I'll redistribute RIP routes into EIGRP and EIGRP routes inside the RIP routing protocol. What is the configuration part then we need to do? We'll see the configuration part that we need to do. R1, R2 and R3. Show IP protocol. There is no protocol running. Show IP interface brief. I'm having the IP addresses configured. Okay, so let us quickly configure as per our plan. So I'll keep the plan over here and this over here. Okay, you are able, you can see, right, the complete screen with the configuration window.
Yes, I can see.
So I'll advertise the interfaces with the same protocol defined as per the diagram. Okay, so on R1 I'm running router RIP version 2, no auto summary, network 10 dot network in the LAN and 1 dot network in the WAN. Let us not take the loopback. On R2 router RIP version 2, no auto summary, network 20 dot network in the LAN and 1 dot network in the WAN. Exit. And on R2 I am having 2 dot network also, which is in my EIGRP router, EIGRP 100, no auto summary, network 2 dot network is there in the EIGRP. Okay, exit. On R3 router EIGRP 100, no auto summary, network 30 dot network, sorry, not 20, 30 dot network and 2 dot network. correct? Now, if I go on R1 and if I check show IP route, I am only getting my connected routes and RIP route, which is my 20 dot network that is advertised in RIP. Correct? I am not getting any routes of R3. Any routes of R3. I am not getting the 2 dot network as well. Neither I am getting the 30 dot network. If I go on R3 and if I check the same command show IP route, the routing table, here I am only getting my connected routes. That's it. I am not getting any of the routes of R2, neither I am getting any of the routes of R1. Okay. If I go on R2 and if I check show IP route, I'll be getting RIP routes. See, R means RIP and D means EIGRP. D means EIGRP. So here we can have both the routes. Both the routes are present on the R2's router. So you can see the from the this output we can see R2 learns the routes from R1 and R3, that is 10 dot and 30 dot networks, okay, respectively. But on R1 and on R3 we cannot see their each other routes in the routing table because they are running different routing protocols. So what we need to do now, we need to configure R2 to make sure, see, R2 is not sending RIP routes to EIGRP, neither it is sending EIGRP routes inside RIP. So we need to make sure that R1 and R3 can see the routes of each other using redistribution. What is the configuration that we need to do? So first I'll advertise the RIP route inside EIGRP. Okay. So whenever I'm advertising RIP inside EIGRP, I need to change the metric value of RIP with EIGRP. So what I will do, I'll use the command redistribute. Redistribute. What you want to redistribute? I want to redistribute RIP. RIP. I want to redistribute RIP with the metric value. Metric. Now it is asking me for the metric. It is asking me for the EIGRP metric. Now what I'm doing over here, I am changing the metric of RIP routes to EIGRP. Okay, because EIGRP will only understand the metric as bandwidth, load, reliability, MTU, delay. Okay, so I will change. So first it is asking me bandwidth. So bandwidth is 1000 suppose. Delay is 2000. Reliability, EIGRP reliability between 0 to 255. I'll give the higher reliability. Load, there is low load. MTU, the default MTU. Okay. So what I've done, I've changed the RIP routes metric and I have advertised the RIP route into EIGRP. This is what we have advertised RIP route inside EIGRP. Now I need to advertise EIGRP routes inside RIP. So I am inside the RIP, redistribute EIGRP 100. 100 is my autonomous system number. Okay. Then metric value. Metric. Now here you have to give hop counts. Okay. So here I can give any hop count. I'll be giving hop count of 3. Hop count of 3. You have to take the hop counts over here. Okay. So I'll give a hop count of 3 over here. Now I have redistributed all the routes of EIGRP in RIP. Now if I go on R1 and if I check show IP route, now you can check I am getting 2 dot network as my RIP route and 30 dot network as my RIP route. You can see over here I have redistributed the routes inside EIGRP route inside RIP, and here you can see I am getting the metric value hop counts as 3. Hop counts that I'm getting as 3 over here. Okay. So I have given the hop counts as 3, but in the network you have to see the hop counts and you have to then give the hop counts. Okay, show IP route over here. Now you can see I'm getting the one dot network as DX. So DX means EIGRP external routes. 10.20.n, 10.n, 1 dot, 10.20.n, 1 dot network. External routes I am getting over here. EIGRP external routes. Understood?
You have defined here hope count, right? Under the EIGRP while doing this redistribution.
No. Inside EIGRP, I gave the metric value, the bandwidth, delay, load, reliability. See, this is inside EIGRP.
So this should be matching with anything like on R3 what is there, or it can be any random number. Like like you have entered 1000, right?
Okay.
1000 kbps. So can we
Mhm.
change if we change it? Let's say if I put 100 mbps, will it run or it is not?
What is the default, if what is the default thing in EIGRP? If anyone wants to be a neighbor in EIGRP, what is the three things that I've shown you?
For EIGRP, K value should be similar.
K value should be same. For
Yeah.
EIGRP to form the neighborship, K value should be same. So
Yes.
whatever I have given over here are the default values.
So these are the default value 1255 and what?
Yes, these are the default values.
Okay. And for RIP you entered 3, right? Metric count 3.
Yeah, so RIP, you can take any metric value. RIP is not, it is not something like it has to match on the neighbor as well.
Okay.
That is why
Understood.
for RIP, I told you that whenever you are configuring, you have to see your network, how many routers are there in between that. So I have just taken a random value of 3. Okay. But in a network, see, there is no more, RIP is no more used. I've just given you an example. Okay. But if you are in a network and you are using RIP, and you have to see how many routers are there to reach that network. In between that in between that network, how many routers are there? So here there is the hop count of one only, but I have shown you the different hop counts considering that there are some other networks also in between and something like this. Okay. You can see on R3 I'm getting external routes that are advertised in EIGRP. Okay, so you can see the administrative distance value is 170. If you remember, I told you in EIGRP, the AD value for external routes will be 170. Internal routes of EIGRP is having AD value of 90. External routes are having AD value of 170 and summary routes are having AD value of 5. Okay. Now if I try to ping from here the 10 dot network, that is on R1, I am able to ping. From R1 also, if I try to ping the 30 dot network, I'll be able to ping. Correct? Understood?
Yes. Clear.
Now what we can do, we can make a change in the plan over here. We can, instead of uh, EIGRP, now we can take OSPF over here. Instead of EIGRP, we can take OSPF. Let it be RIP over here. Okay. So one by one, we'll see all the things. So what I need to do, I need to go on R2 and I need to say no router RIP, no router EIGRP 100. All the configurations will be deleted. Okay. On R3 also, I need to say the same thing. No router EIGRP 100. Now if I see show IP route, I'm only having the RIP route, that is my 20 dot network and my connected network on R1. Okay. Now I need to configure OSPF. Okay, so configuring OSPF, you know the configuration, how to configure OSPF. Network on R2, I will say 2 dot network will be in OSPF with the wildcard bits as this. Area you can take 0, and on R3 router OSPF 1 network 30 dot network with the wildcard bits as this, area 0, 2 dot. Okay. Now I formed the neighborship with the router R2. Now if I try to check the show IP route, here I am only having what? I am only having the connected routes. Okay, the RIP routes are not advertised over R3. If I go on R1 and if I check show IP route, I have shown you I am only having the RIP routes over here. The OSPF routes are not there over here. Okay, understood? Now, if I want to get the RIP routes as well as if I go on R2 and if I check show IP route, I'll get the RIP route as well as the OSPF routes. RIP routes as well as the OSPF routes. Now, what I need to do, I need to configure R2 and I need to make sure that R1 and R3 can see the routes of each other using redistribution. Okay. Now here on R2, if I am redistributing RIP routes in OSPF, so what is the command? I need to go inside the router OSPF and I need to say redistribute RIP. This is same. Then here, if I'm inside the uh, OSPF, see, OSPF uses something known as subnets. Okay, it considers subnets for redistribution into OSPF. So whenever I am redistributing any routing protocol inside OSPF, I have to use a command known as subnets. Okay, redistribute RIP subnets. This is compulsory. This is compulsory, and the metric value is, you can say, it is not uh, compulsory over here. Metric is not compulsory. Okay, metric if I say, but this redistribute RIP subnet command is compulsory over here. OSPF will be using subnet command over here. Subnet, you have to use subnet command over here if you are redistributing any routing protocol in uh, OSPF. Okay, subnets. It works on subnet. It considers subnets for redistribute in OSPF. Now, if you just give this, if you don't uh, configure the metric value, then by default it will take metric as E2. By default, it will take metric as E2. Okay, so let us see first by not defining this. I will just define this. I have given the things. Okay. Now I have given you the difference between E1 and E2. If you remember the last lecture, I have given you the difference between E1 and E2 routes.
Yes.
OSPF.
Yes, I remember.
So router RIP. Now I will redistribute the OSPF routes in RIP. So when I'm redistributing OSPF route in RIP, I need the metric value as hop count. So suppose I'll take a metric value as 5. Now if I go on R1 and if I check show IP route, you can see I'm getting the 2 dot network and 30 dot network as my RIP routes because R1 is running RIP. Okay. If I go on R3 and if I check show IP route, I am getting OE2 routes. By default, it will take E2 routes, type 2 routes. Okay, by default, it will take OE2 routes by default. If you don't give any of the, if you don't select any of the metric values. Now, if you want to change, if you want to be specific, like it should select type 1, then you have to remove this, not this, this, and you have to say redistribute RIP into subnets and select the metric. Now you can see over here, metric, then the metric value you have to give. What will be the metric value between the on this router when OSPF is getting redistributed, when OSPF is getting redistributed, what will be the metric value? So suppose I'll give the metric value as 100. Okay, I'll give the metric value as 100. Now it is asking me what is the metric type. Now see, previously I have not given any metric value, neither I have selected any metric type. So if you don't select, if you don't give any metric value, it will, by default, it will take the metric value as 20. By default, it will take the metric value as 20 and the metric type as E2. Here you have two types of metric type. You can see if I give metric type, you have type 1, set OSPF external type 1 metrics and type 2. So I have seen the type 2. Now I will configure type 1. Show IP route. You can see OE1 routes I am getting, and the uh, metric value you can see it has taken as 164. 164. 164 over here. The metric value as 164 over here. 100 is the thing that I have given, and the 64 is the default metric value between these two routers, or something it is calculating. Okay, understood?
Yes.
Difference between E1 and E2 routes.
Yeah.
Theoretically I have shown you that day. This is something practical representation. Check the connectivity. I am able to ping. Any questions?
No question. One more redistribution, right?
Yeah,
Like EIGRP and OSP.
yeah. So here I'll remove the RIP, and here I'll be running EIGRP. Same configuration, same things. Just I'll be running EIGRP over between. I've just removed the RIP configurations and I've just running EIGRP over here. Okay. So OSPF is still there. Just I need to remove the RIP configuration, no router RIP. And R2 as well, I have to say no router RIP. And you need to configure router EIGRP 100. Router EIGRP 100. No auto summary, network, 10 dot network, 1 dot network. That's it. Router EIGRP 100. Okay. No auto summary, network, 20 dot network, and 1 dot network. Okay. And I'll remove that, whatever the inside the OSPF, whatever we have given the redistribution command. Got it? I've configured the neighborship is up, show IP route. Here I am getting the connected and D routes, that is my EIGRP routes. I am getting the connected and my D routes over here. Now I'm not getting my OSPF route that are there on router 3. I'm not getting that routes. On R3, I will be not getting the routes that are there on R1 and R2. Correct? Now the commands are same. You can see to configure, I need to configure it on R2 only because R2 is running both the routing protocols. So I'll say router EIGRP 100. First, I'll redistribute the OSPF route inside EIGRP. So when I'm redistributing OSPF inside EIGRP, then I have to configure the OSPF route metric as EIGRP metric. I have to convert the OSPF routes in EIGRP metric. So I have to say redistribute OSPF 1 with metric values as 1000, 20,000, 255, 1 and 1500. Okay. Then router OSPF, inside OSPF, I need to redistribute EIGRP route. So I'll say redistribute EIGRP 100 subnets. If I don't select any of the metric value, it will take by default as 100 and the metric type will be E2. Metric type will be E2 and metric value will be 20. So IP route. See, I got external routes DEX, the 20 dot, the 2 dot and the 30 dot network as my external routes in EIGRP. Correct? On R3, if I see show IP route, I'll get OE2 routes, the 1 dot, 20 dot and 10 dot network. And by default, they are having the metric value as what is given over here. Understood? If I check the connectivity, I can be able to ping.
We can make this as a E1, right?
Sorry?
We can make this as a E1, right?
You
External
can
one
make this
command,
what?
external one route E1,
E1
right? Right?
routes. Yeah, we can make it as E1 routes. We can make it that E1 routes. We can also change the metric value. Okay. We can do as per our whatever we need, as per our requirement.
Okay.
Any questions? Okay. Now I have a task for you all. I will give you a mock lab, a task that you need to configure. These loopback, suppose they will be in RIP. They will be in RIP. Only loopbacks will be in lib. Okay, then these LAN and this 1 dot network in the WAN, they will be in EIGRP. Suppose EIGRP, they will be in EIGRP 100. They will be in EIGRP 100. Okay, understood? Till here, this is the thing.
Okay.
Now between these two, suppose I'll be running Ospf. This between these two, suppose I'll be running Ospf. Okay, take the take this LAN also in it. Don't take the loopback addresses. Okay, just take the LAN addresses wherever I have given the things over here. Now between these two, suppose take the this and this, and again here you will be running rip.
Between R2 R3 OSPF, right?
Between R1 and R2 OSPF. Yes, just a second, I'll write over here OSPF. Okay, and these R4's loopback, they will be also in EIGRP. EIGRP. R4's loopback will be also in EIGRP. Okay, suppose EIGRP 100. Got it?
Yes.
You'll be able to do it, right?
Yeah.
Okay. So this is a mock lab in which all the things are there. RIP to EIGRP, EIGRP to OSPF, OSPF to RIP, RIP to EIGRP again. Okay, all the things are included over here. So you have to complete this thing and you have to show me. Okay. Any questions still here in redistribution? Any questions? Hope so, no questions. Now we'll move to next topic, next part. Okay, as I told you, we have completed our redistribution. We'll move to route filtering. Route filtering. Controlling routing update traffic. Route filtering. So route filtering. Now, why we need route filtering? What is route filtering? Route filtering, you can say it is a process to allow or deny specific routes when they are advertised to router or they are received. Okay, so why do we need route filtering? So if we need to advertise only some specific routes to neighbor, okay, for security reasons. Okay, for some security reasons, if we need to advertise only some specific routes, or if we are redistributing some specific routes. Okay, if we are redistributing, then if we want to just redistribute some specific routes, then in that condition we need something known as route filtering. Okay, preventing redistribution loops, you can say preventing redistribution loops. Okay, so in some of the situation, these are the routes that are there. Okay, these are the things that we need in when we are advertising. Only when we need to advertise only some specific routes to the neighbor for security reasons, then we need something known as route filtering. We need to filter the routes. Okay, so you can see over here, advertise some specific routes to the neighbor, redistribute some routes, or preventing redistribution loops. Okay, so you might need to control exactly which routes to be advertised or redistributed, or which path to be chosen. Okay, and you can advertise only specific routes to the neighbor. Path manipulation of specific routes. You can change the metric or metric type for specific routes. Okay, like what we have seen in this, all the routes are having the same metric value, E2, E2, E2. Now I want that for specific this route for one dot network, when it is getting redistributed, I want that these routes should be uh, redistributed as my even routes. Okay, only this one dot network should be advertised as my even routes. Okay, so these are some things that we can do. These are the things we can do with route filtering. Change the AD value for specific routes. With BGP we can use policy based routing, we can do. Okay, so there are different types of route filtering methods that we can do. Passive interface, distribution list, then we have prefix list, then we have route map, policy based routing. We will see all of this. Okay, we'll see one by one all of this. Okay, so why do we need route filtering methods? We need route filtering methods for, you can say, sometimes we are having some policies to policies to be configured. Okay, uh, like we need some policy based routing, or some path manipulation of some specific routes, or we need to change metric and metric type for some specific routes, changing the AD value for some specific routes. In this type of scenarios, we need something known as route filtering. Okay, route filtering methods. Understood? Any questions?
No questions.
Now, first thing that we'll be seeing is route map. Route map. What is route map? Route maps are, you can say, similar to scripting languages for these reasons. Okay, so let us not start with route map. Just give me a second. Hmm. Okay, let us start with route maps only. So route maps are similar to scripting languages for these reasons. Okay, they are similar to scripting languages. Okay, so they work with more sophisticated ACLs. More sophisticated ACLs. They offer top-down processing like our ACLs does. Top-down processing. Okay, top-down processing. Once there is a match, it leaves the route map. Okay. Line are sequence numbered for easier editing. Like in ACLs, we have the sequence number. Okay, the lines are also given as sequence number for easier editing. Insertion of lines, deletion of lines are easy. And route maps are named rather than numbered for easier documentation. Okay. Now match criteria and set criteria can be used. It is similar to if else logic. If else logic, what does the if else logic? If you have studied any programming, you must be knowing about if else logic. If I'm inside any, if I want that it should be having several conditions. So if this condition matches, then run this code, else run this code. We give two types of codes over here. If a condition matches, then run this code. If it does not match, then run this code. So if it is same, if else, if it is as it is an if else logic. If route maps runs as if else logic. Okay. Now common use of route map are as follows. When we are using redistribution route filtering, a more sophisticated alternative to distribution list. Okay, so that is the reason I was not taking this route maps first, because you need to understand distribution list also first. So let us change the topic. First we will start with passive interface. We'll go line by line over here: passive, distribution, prefixed, then route map and PBR. Okay, so prefix passive interface. Passive interface is something that we can have in RIP, EIGRP, and Ospf. Now, passive interface is something like it is used to disable updates out from a specific interface. Okay, like if I'm having some, you have taken a screenshot of this, right?
Yeah, I took.
So if I'm having some network over here, suppose there are some routers over here that are connected with each other. One router over here, suppose one router over here, they are connected with each other. In some form, they are connected with each other like this. Okay. Now, passive interface is disabling updates out of a specific interface. Okay, disabling updates means disabling sending multicast updates. If you are using, suppose RIP, if you are using RIP over here, if I'm using RIP over here, suppose, okay, now disabling sending multicast updates via specific interface. Like if I want that these are the interfaces. Okay, if I want that it should not send updates, RIP updates on this interface, then I will stop the RIP updates on this interface, making this interface as passive interface. If I make this interface as passive interface, it will not send multicast updates via this messages, via on this interface. Okay, so if you want that there should be no RIP updates over here, because it will get loop over here sometimes. Like if you are running RIP over here on these routers, between these routers, and if you are sending RIP routes over here, they will come back over here from here also, and it can get looped over here. So I'll make this interface as passive interface, that it should not send any RIP updates on this interface. Okay, so it should not form a loop. Now I can do it with EIGRP also.
Sorry,
EIGRP.
there is one more purpose, right, for the passive interface configuration.
Yeah, you can tell me what?
So let's say if on a router, if one interface is going to the customer or client side, okay,
Yeah.
and
So
we do,
if you're,
yeah,
yeah, if you're suppose some service provider, and if you want to don't share the routes with the customer or something, then you can make that interface as a passive interface. So there
okay,
are
yeah, it will
multiple.
listen those, it will listen, but it will not export the routes, right? It will capture all the routes, but it will not export.
Yeah, it will listen to incoming packets like you can see over here. Allow listening to incoming packets from other RIP speaking neighbors, but it will not send uh,
Yeah, got it.
multicast updates via a specific interface. Okay. It will listen to the routes in RIP. It will listen to the incoming updates from the other RIP speaking neighbors. Okay, but it will not send the routes. In EIGRP, it do not send any hello packets, hello messages on passive interface. Okay, it will not send any hello messages on the passive interface. Okay, and router ignores any EIGRP messages received on the interface. There is no neighborship. There is no neighborship. Understood? There is no neighborship between the routers if we are configuring a route. See, why we need, what we can do in EIGRP. Suppose I am having a router over here, okay, and there is a LAN network connected over here. And there is some router, another router connected over here in the WAN. Now, sending hello messages on this interface will not do anything, because when we configure EIGRP, it will send out hello messages on all the interface. Now sending hello messages on this LAN interface will not get anything. Okay, so what I'll do, I'll make this LAN interface as passive interface. Still it is connected, because it is connected, we are not connected to any of the neighbor. I'll make this interface as passive interface, so it will limit the number of hello packets. It will limit the number of hello packets. EIGRP still advertises about the connected subnets if matched with an EIGRP network command. Okay, so what I did, I made this my LAN interface as my passive interface. So what it will do, it will not, it will still advertise the connected subnets, but it will not send, the router will not send any hello packets on this interface. Okay, no hello packets will be sent. Okay, because I will not receive any hello packets from here. I'll not receive any messages from here, from the LAN. Okay, so router in this type of scenarios, we need passive interface. Okay, understood? Same as OSPF concept is same, like EIGRP in OSPF passive interface works just like it does in EIGRP. Do not send any hello messages on passive interface, no neighborship. Still, it advertises about the connected subnets if matched with an OSPF network command. If you have advertised it in OSPF or EIGRP with a network command, it will show you the routes. It will show you the routes. Okay, the connected routes. Understood? Let us see practically. No IP routing. Okay, so first we will have a look on, we will take R1, R2 and R3 only. We'll configure RIP first. Okay, all the routers will be running in RIP and we'll do some task over here. Okay, I'll give you some task over here. So let me first advertise all the routers in RIP, all the networks in RIP. Version 2, no auto summary. Network, 10 dot network, LAN and WAN. I'll just advertise LAN and WAN. That's it. Okay. Router RIP version 2, no auto summary. Network, 20 dot network. Then I have 2 dot network and 1 dot network. 2 dot network is connected between R1 and R2 and R3. On R3, router RIP version 2, no auto summary. What are the network over here? Network, 30 dot network and 2 dot network. And let me advertise the loopback also over here to see some things. 13 dot network. Now if I see on R2, if I see show IP route RIP to be specific, I am getting the 10 dot network, the 13 dot network I am getting over here. What about the 30 dot network? Now I got the 30 dot network as well. So the 30 dot network is also there, 13 dot networks and individual routes I am getting over here. And if I see on R3, show IP route RIP to be specific. So what I'm getting over here, 10, 1 dot, 20 dot and 10 dot network. Okay. 1 dot, 20 dot and 10 dot network I am getting on R3. Okay. So now I'll configure R3, R3 serial 3/1 that is connected to my R2. I'll configure that is facing R2. I'll configure it as passive interface. I'll configure it as passive interface. Okay. So let us check what happens if I configure this interface as passive interface. Serial 3/1. Now to make this interface, sorry, not serial 3/1. I need to say router RIP and I need to say passive interface serial 3/1. Inside router RIP, I'll say passive interface serial 3/1. Okay, I've made it. Now clear IP route star. Show IP route RIP. It is getting converged. See, I am getting 10 dot, 20 dot and 1 dot network as I was getting. I am getting the 20 dot network from R1. Okay, you can see. But if I go on R2 and if I check show IP route RIP, let me clear over here also, because RIP we need to clear the routing table. Okay, see, I am not getting any of the networks that are connected to R3. I am only getting the network of R1. You can see R3 stopped sending RIP updates on interface serial 3/1 as the interface was configured as passive. No routes from R3 can be seen in R2's routing table. Okay, but R3 is will be able to receive RIP updates on the interface facing R3 that I've shown you over here. R3 is getting the RIP updates over here. Okay, understood?
Here you made interface as a passive inside the router process, like router RIP protocol.
Sorry,
Can't
come
we
again.
cannot we make passive interface on global config?
I cannot hear you properly. Can you speak a bit louder?
Is it okay now? Hello.
Yeah,
Okay. I'm asking, can we make passive interface command in global config?
global configuration mode.
Yeah.
So you have any command for that?
No, I'm asking, will it make changes? Because uh, here you have entered it under router RIP, right?
Yeah, I have given inside the RIP, I have given the command.
So this we do inside the routing protocol, or we can do on the global config mode also.
So I have not seen in the global configuration mode.
Okay.
I have only done, if you have any command, you can give me.
No, I don't know. I'm asking.
Okay. You have to go inside the routing protocol and you have to make that interface as the, okay, inside the, suppose you are running EIGRP or any of the routing protocol, then you have to give the passive interface command inside the uh, inside the router mode. Understood? This is only the step. Or if you want to give, uh, you can select the in any of the routing protocol, you can give with the same things. Okay, like passive interface and the things over there, you can give it same ways. Understood?
Yes.
Okay, so this is what about RIP is there. Now here are the commands that I have shown you for OSPF. The commands are same, passive interface. Okay, the commands are same. Okay, you have same commands running all over the any of the routing protocol, whether it is RIP, whether it is EIGRP, whether it is OSPF, you have to give the same commands. Okay, so I need you to do it by yourself for EIGRP and OSPF. Okay, understood? If I remove from here, if I go on R3, if I remove the passive interface configuration and if I check it on R2, if I clear IP route over here, I am getting all the routes now. Understood?
Yeah, great.
No.
I got it.
Yeah. This is something passive interface. Then we have the next thing is distribution list. Now distribution list is something is used to control routing updates. It is used to control routing updates. Okay, so distribution list, it is used to control the routing updates. Either they are coming to your router or leaving from your router. Okay, it is used to control the routing updates. Distribute list work on a variety of different iOS routing protocols. Now, this is one of the easiest way. This is one of the easiest way to you can say control the routing updates. It uses an access list, or you can say a route map or prefix list to permit or deny the routes. So first we will start with access list, and then once we'll study the prefix list, we'll see how to implement distribution list with prefix list. Then once we'll study route map, we'll see how to implement distribution list with the help of route maps. Okay, so we already know about access list, how access list work. It is the we have already studied at the CCNA level. So use an access list. It uses an access list to permit or deny the routes, can be applied to transmitted or received or redistributed routing updates. Okay, we can apply it on any type of updates. Either if we are transmitting anything, if we are receiving any routes, I don't want to receive specific routes. So I will say I will use this distribution list command, or if anything is redistributing into other routing protocol, in that also I will use redistribution, sorry, distribution list. Like over here in this example, you can see what I've done. I am running EIGRP over here, EIGRP1, okay, and I'm having 172 and 192 network on router B, okay. And what I said this 10 dot network or this 172 dot network should not be advertised over the internet, or this is something internet or something. This should not be advertised. So what I said distribute list 7. This is the number of distribute list. Out the whatever is going outside, you have to make a change. You have This is the number of the access list, and you have to check the access list 7. So whatever is given in the access list 7, you should not advertise this network outside this interface. Understood? Distribution list. You can control the routes. You can control the routing updates to send it somewhere out of the interface. Okay, like here in this example also you can see. Now I have created two access lists over here to permit 10 dot network, over here to permit 10 dot network. Okay, now what I've said, router rip network 10 dot network, I have advertised over here. I've said passive interface, I've made one of the interface over here passive. Okay, and redistribute ospf 1 metric 5. Okay, I've redistributed my ospf routes inside the. Why I have made this interface as passive interface, any of the interfaces passive interface? We have redistributed the OSPF routes in RIP and RIP routes in OSPF. Okay, both the things I have done over here. But why I have made this interface as passive interface, S3 interface? Suppose any of the interface is S3. This interface is S3. Why I have made the interface as passive interface? See, I am redistributing the route, so I can get the routes from here also. This is also the path. This is also the path. So it can get looped. It can get looped. So what I will say, I will make one of the interfaces passive. So it will only receive, it will not send any updates on that interface. So to stop the loop, I have made the interface as passive interface. Okay, then I've configured a distribute list, and I've said distribute list. I've configured distribute list with access list 3 out of the OSPF, out of OSPF, any of the interface. So we'll see practically how to configure distribution list. Okay, how to configure distribution list, we'll see practically. So here I already have the RIP configuration, so I'll keep it as it is. I have removed all the things. I will keep it as it is. Okay, the RIP configurations, I'll keep it as it is. Okay, then what I'll do, just I'll go on my R1 and R3 and I'll advertise R1 and R2 and I'll advertise the loopbacks over here also. R1 and R2's loopbacks also. Okay, I've advertised R1 and R2's loopback also. Now if I go on R2, I'm on R2 only. If I check show IP route RIP, I'll get the RIP routes as 11 dot and 10 dot and 13 dot and 30 dot network. All the routes I'm getting over here. Okay, and all the routes are individual routes. You can see because I've disabled the auto summary. All the routes I'm getting the as individual routes. If I go on R1 and if I check show IP route RIP, I'm getting the 2 dot network, the 20 dot network, 12 dot, 13 dot, and 30 dot network. Okay. And if I go on R3 to check the routing table, show IP route RIP, I'm getting here all the routes. Okay. Now I need to configure R3, that R3 should not send 13 dot network, means R3 should not send 13.0.0 and 13.0.1.0. These two networks R3 should not send when it is sending and RIP updates to R2. Okay, I want only these two networks should not be from being advertised to R2 using distribution list. What I want, 13.0.0.0 network and 13.0.1.0 network should not be advertised to R2. And I have to do this by using distribution list. So how I can do, as I told you, I need to create access list to match the network. So I'll create access list 15. I'll say deny what? 13 dot network 0.0.0.255. Okay, deny. I want to deny this network and this network. Okay, and I'll say permit all the others. Access list 15, permit any. Standard access list. Okay, now I will configure distribution list. How to configure distribution list? I have to go inside the router mode, router RIP. I need to say there is a command over here, distribute list. Filter networks in routing updates, distribute list. So I'll use the command distribute list. Then what it is asking me, it is asking me the access list number. So access list number is 15. Then it is asking me what is the direction of the network. So if this is the loopbacks, they are going outside from this interface. They are going outside from this interface. They are going outside from this interface. So what I will say, I will use whatever, if any routes are going out from serial 3/1 interface. Okay, out direction. I can configure it on R2 as well. What I can do, I can configure it on R2. I can say access list so and so and distribution list 15, and whatever routes are coming in this interface, inside this interface. Okay, but I'm doing it on R3. So if any routes are going out this interface, you have to check the access list 15. Okay. Now, as this is RIP routing protocol, I have to clear the routing table. Show IP route RIP. Now you can see the 13.0.0.0 and 13.0.1.0/24 is been removed. You can see. And you see, we have eliminated the routes to be advertised.
Yeah.
To R2 using distribution list.
Yes.
Okay. Understood?
Yeah. Can you go on R3?
R3.
And just, yeah. And show IP interface serial 3/1.
So IP interface serial 3/1.
I just want to see how can I see the distribution list what I have created. Any show command?
Any show command for distribution list?
Yeah. What distribution list I have configured over interface?
I don't think so. So distribution. No, there is no such command for distribution list. Okay.
Like if you run show IP interface serial 3/1.
This is the IP interface thing. Whatever I've shown
No,
you.
and then you put pipe include access list. We get access list, right? Include pipe. Include access list. That's it. Enter.
No, you will not get access list. You will get access list with simple command show run pipe section access list.
Okay.
If you want to see the access list, you have not done the access list on any interface.
Oh, that's why it's not coming.
Not configured it on any interface. You have configured it on the global mode. So why you will see inside the interface?
So distribution list we cannot see here, right? Then
If I give
while
show
troubleshooting,
run,
no, yeah, while troubleshooting, it will be really difficult to know why this route is not
we
coming.
can see it in the router mode. We can see what is the
Here it is. Yeah,
configuration in
here
the
it is.
router mode.
Okay, okay,
Because we have done it in the router mode, router rip mode.
okay. So it will come under show running config or show IP.
Show running configuration.
Okay.
Okay, if you want to be specific, show run pipe section router rip, or you can give rip. Just you give rip, you will get the rip configurations.
Okay.
Understood?
Yes.
Okay, now as I told you, I can configure it with the on R2 also in the in direction. So if I remove this configuration router rip, remove the distribution list. Okay. And now if I go on R2 and if I clear the routing table and if I check, now I'm getting all the routes. Both the 13.0.0 and 1.0 are advertised over here. If I want to do it on R2, same process is there on R2 as well. Okay, so same process is there on R2 as well. So I'll say access list. Access list 15, deny 13.network. Now I can use summary for this 13 dot network. Okay, and I can say access list 15 permit any, then router rip distribute list, see the 15 whatever is coming inside serial 3/1, clear IP route star, show IP route rip. See, both the routes, both the networks are been removed. Okay, both the networks are been removed. You can see because I have given in direction whatever is been advertised. If they are advertised from the these networks, those networks that are listed with the access list, you have to remove that networks. Understood? Any questions?
No questions.
Okay. Now we can do multiple tasks over here with the distribution list. Okay, we can do multiple things. Like if you want to deny all of the 4 networks, you can list down all of the 4 networks in the access list, and you can deny the all of the 4 networks, all of the 4 this loopback addresses to be denied to be advertised on R2. Okay, understood? Any questions? Anything you want to ask? So we don't have a time to start a new topic. So what I will do, I'll just show you the to remove all the loopbacks. Okay, I'll just remove all the configurations, whatever I've done. Here there is no configuration. Clear IP route star, show IP route rip. I am getting all the routes over here. Now here there is some access list that I've created. Access list 15, do show access list. Access list number 15 I've created. I already have 2 networks denied. I can deny other 2 networks 13.0.2 dot network, sorry, 0.0.0.255 deny. I'm giving it after permit. What will happen? Will it deny these? No. So I have to remove the access list. So suppose I will create some new access list 30 deny 13.0.0.0 0.0.0.255 1 dot 2 dot and 3 dot, all the 4 loopbacks. What I need to do, router rip I need to say router rip distribute list, use the access list 30 whatever is going outside serial 3/1 interface. Previously I was getting all the 4 networks. Now if I see, I will not get the 13 dot network, any of the 13 dot network. I will not get any of the 13 dot network. Understood?
Yeah. Okay.
Any questions? Any doubt? Anything?
Nothing from my side.
So I've given you a mock lab for redistribution. You have to complete that mock lab and you have to show me. Okay. In tomorrow's lecture, you have to show me the things.
Okay.
Okay, so we'll stop over here. The recordings will take the time and we don't have much time. In 7 minutes, we cannot complete a new topic.
Yeah. We'll do tomorrow.
So we'll stop
Give
over
one
here to.
question. Will you be sharing some like dump for examination purpose or some workbook?
See, dumps are paid dumps. They are not freely free. They are paid dumps that we are having available.